We will actually learn two different distance formulas this year. This one specifically works if you're talking about a number line. Distance in this case is going to have an absolute value involved. And you are simply going to take whatever the value of a coordinate is, A, and you're going to subtract the other coordinate, B. And it's going to be the absolute value of that because distance has always got a positive value. We never talk about value as being negative. I gave you a brief idea of what this actually represents on Friday. I said this and this have two different meanings. This is red, the segment RW. When it says find RW, they're saying find the distance or the length of RW. In other words, RW in this case represents a variable. We're looking at actual length. And since I know the formula is the absolute value of A minus B, the coordinate of R is 4. The coordinate of W is a -2. Minus a negative would become plus a positive. And 4 plus 2 would be 6. So RW in this case would be 6. Likewise, we're going to do the same thing for XY. We're going to use the absolute value. It says X is 0. I'm going to put in that coordinate. Minus Y, which is 6. So it says I'm taking the absolute value of a -6, which is what? 6. Remember, distance will always be positive. And this formula works if you're talking about a number line. We will learn another formula when we're talking about the distance on a coordinate plane. Likewise, when they're talking about a midpoint is something that's creating two equal parts, two equal segments. In other words, it's directly in the center. The midpoint formula on a number line says if you take A plus B and divide it by 2. So, for this example, we are going to find the midpoint of RW. So I'm going to take the coordinate of R, 4, the coordinate of W, -2, and I'm going to divide it by 2. 4 plus a -2 is 2, and 2 divided by 2 is 1. And just from a picture standpoint of view, if I plotted that point, you can see that from this green dot to W, there's 1, 2, 3 spaces. From the green dot then to R, there's 1, 2, 3 spaces. You can see that it created two equal pieces out of that segment. Likewise, if I'm finding the midpoint of XY, X coordinate is 0, Y coordinate is 6, 0 plus 6 is obviously 6. 6 divided by 2 is 3. And again, if I were looking at that coordinate, from X to the blue dot, 1, 2, 3 units. From the blue dot to Y would be 1, 2, 3 units. So you can see it's directly in the center, midpoint. It's creating two equal parts. Questions on our distance or the midpoint? Yep.
So instead of just adding like two variables with another one?
Yeah, you're taking the coordinate from that and the coordinate from that, you're adding them together and dividing it by what? 2. Here, instead of adding them together, what are you going to do with them? Subtract them, and you're going to take the absolute value of that distance. Questions? Can I go? Segment addition is actually a postulate. It says if 3 points are collinear, so notice A, B, and C are collinear. It says B is between A and C, so notice that it's in between it. That AB, in other words, the length of AB, plus BC, the length of BC, is going to be equal to AC, in other words, the length of the entire segment. They're saying if I take AB plus BC, that it's going to be equal to AC. And that should make common sense. Now, a lot of times in geometry, they'll give you a picture like this, and they'll ask you to do several problems from the same picture. If they do that, these problems aren't related to each other. Problem 5 has nothing to do with problem 6. We're just sharing the same picture. In problem number 5, it says DE equals 2. I'm going to put that 2 up here in the picture for a minute. It says EF is equal to 7. And it says find DF. In other words, find the whole thing. Well, obviously, DF would be equal to whatever DE is, plus EF, in other words, 2 plus 7, which is what? 9. I certainly don't expect you on these easier problems like that to write this out. I just wanted you to see where these came from. Using segment addition, it says if I take part of the segment, DE, I take the rest of the segment, EF, that it's equal to the whole segment, DF, which is what they're asking me to find. When I go down to the next problem, it has nothing to do with what I've put there, so I'm going to kind of erase these numbers that I put in. And I'm going to start over again. In this problem, they said DF is equal to 41. In other words, the whole thing is 41 units long. They said EF was 33, and they asked me to find DE. How would I find this one? I'm going to end up subtracting 33 from 41. Algebraically speaking, if I put a variable there, this would say x plus 33 equals 41. But if you can see it, all you're going to do is what? Subtract 33 from both sides, and DE is going to be 8. Again, the next problem doesn't have anything to do with what I put up there already. So DE is 14. It says DF is 37. And it asked me to find EF. Algebraically speaking, this again would be 14 plus x equals 37. Or I'm going to take 37 and subtract 14. And if I do that, I am going to get 23. Segment addition is a postulate. The segment addition postulate says if you take part of a segment, you add another part of the segment, it's equal to the whole segment. Are there questions on segment addition? So in example 8 here, they're asking me to find the value of x. Notice it's not one thing that I have to find. It says find x and PM. So I've got to find out what x equals, and I also got to find out what PM equals. That's what the question's asking me to find. And this is why we spent time working on our algebra skills up front, is because we're going to use the segment addition postulate to figure this out. It says if I take part of a segment, in other words, the distance from P to M, 7x, I add another part of the segment, the distance from M to Q, 5x minus 3. It should be equal to the whole segment, which they told me was 45. If I combine my like terms, 7x and 5x is 12x. Adding 3 to both sides, 12x is equal to 48. Dividing by 12, x is equal to 4. From a geometry standpoint of view, I would say the biggest mistake that I see people make on this type of problem is when they get x equals 4, they're done. That's the only part of the problem they actually do. Because in algebra, once we found the variable and what it was equal to, did we have to go any further? No, we were done. What else did they ask me to find? PM. So if I know x is 4, if I knew PM was equal to 7x, what can I put in place of this x? 4. So I'm going to take 7 times 4, which is 28. So there are my two answers that they asked me to find. X is 4 and PM is 28. For the sake of time, I'm going to skip example number 9. I think you can see what we're going to do. It says AB is 5y minus 1. It says BC is 4y plus 2. We're going to add those two together and set them equal to what? 28. But it's the same process. I do want to talk about things that are congruent. Yep. Yeah. Oh, no, I missed it. It's possible that I even wrote it down wrong when I missed putting it up there. Negative 3 over 20. Am I good? Can I go to the next one? This is more notation than anything else. If they're telling you two things are congruent, they'll put little hash marks on. If you look at AB and XY, they both have two little marks on them. In other words, they're telling you the length of AB and the length of XY are exactly the same. If two things are congruent, they have the same measurement. Symbolically, this would look like this. Segment AB, the congruent symbol is an equal sign with a little squiggly line over the top. And it would be congruent to segment XY. The definition of congruence says if this is true, then this is true. If two segments are congruent, then their lengths are equal. A bisector, line RS, bisects segment PQ. If it bisects it, it will create two congruent parts. And you'll very seldom see me write out that word congruent anymore. Once we've used that symbol, I'm just going to stick that symbol in there. In other words, segment PR is congruent to segment RQ. If RS bisected PQ, it created two congruent parts. Notice they only put one little tick mark on it. If they put two on this one, they'd have to put two over here. And they do distinguish sometimes. They put one mark, they put two marks, they put three marks. It just depends on how many congruent pieces they have in the same figure. Can I go? Okay. Again, I'm only going to do one of these from this picture. I think you'll get the idea of the other ones. I'm going to do example 10. It says AE equals 30. I'm going to write that in this picture. It says ED is equal to 2x plus 6. And it asked me to find x. What can you tell me about AE and ED? They're congruent, or they have equal measurements. If I know two things are equal, then that's all I have to do is set them equal. I know 30 should be the same as 2x plus 6, so I set them equal to each other. And I solve this like I would any other algebraic equation. I'm going to subtract 6 from both sides. I now have 24 equals 2x. And I'm going to divide both sides by 2, leaving me x is equal to 12. These are all going to be somewhat the same. There's your assignment. It's out of the workbook. You need to do 1 through 20, then 22 through 32. And when it says 1-3, which form are we doing? Form G.